In this session, we introduce the concept of the divergence. So give the definition and then do one or two examples on the same. So let V be a differentiable vector field. So V is a differentiable vector field. Then the divergence of V denoted by or we write it as div V is defined by so the divergence of V is given by partial xi plus partial yj plus partial z k dotted with, so V is written as V1i plus V2j plus V3k. So just to make this one clear, you can say let V be this vector given as V1i plus V2j plus V3k, which on working out this will give the partial V1 partial x plus partial V2 partial y plus partial V3 partial z. So remember, we have just made use of the fact that when you dot two vectors, then you simply multiply, get the sum of the product of the components of the I, j, and k. So this is how we define the divergence of a vector V. Now, from this definition, we know that to define divergence, then you need a vector, but then the final result will be a scalar quantity. So note divergence of V is or defines a scalar quantity. So divergence defines a scalar quantity. But then remember, to define the divergence, you need a vector, not a scalar function. So let's do an example. So given that our vector is given that we have a vector V defined by x squared zi minus 2y power 3 z squared j plus x y squared zk. Find the divergence of V at the point 1 minus 1, 1. Now to solve this, we start from definition that divergence is given by divergence of V, which is the same as this scalar product, is partial V1 partial X plus partial V2 partial Y plus partial V3 partial Z, where the vector V is given by V1I plus V2J plus V3K. So this is from definition. Now, this implies that divergence of V is given by, now when you differentiate, this is our V1 with respect to X, we'll get 2X Z, and then plus, when you differentiate this coefficient or this component of J by Y, you get minus 6y squared z squared. And then when you differentiate this k component by with respect to z, you'll get x y squared. So this means that the divergence of this vector v at the specified point 1 minus 1, 1 is given by 2 times 1 times 1 minus 6 minus 1 squared, then times 1 squared plus 1 times minus 1 squared, which will give us 2. I remember this is squared and then positive 1 squared. So this will give us minus 6, then plus 1. So when you work out this is the same as 3 plus 1 minus 6, 2 plus 1 minus 6, which is the same as 3 minus 6, and the answer would be minus 3. So therefore, the solution to the given problem is given by minus 3. And then problem 2, if we have vector v given by x squared plus x squared z I plus 2y cubed z squared j, and then plus x y z squared k, find divergence of v. Now this is more or less the same as at the previous appetizer. So solution will be divergence of v, which can be written as this scalar product, is the same as partial v1 partial x plus partial v2 partial y plus partial v3 partial z. So remember, this is our v1, this is our v2, and this is our v3. So this will be given by differentiating this term with respect to x, we get 2x z, and then plus Differentiating this j component with respect to y, we get 6y squared z squared. Differentiating this k component with respect to z, we get 2x y z. So therefore, the divergence of the given vector is given by 2xz plus 6y squared z squared plus 2xyz. So this is the correct solution. Now, before we do the next example, let's define what we mean by solenoidal vector. So if you work out the divergence of a given vector and you end up with a zero value, then that vector is called solenoidal. And say vector field. So given a vector field V, which is the same as V1I plus V2J plus V3K, then V is said to be solenoidal. If divergence of V equals to 0, i.e. V is solenoidal if partial V1 partial X plus partial V2 partial Y plus partial V3 partial Z equals to 0. So that's the definition of a solenoidal vector or a vector field. Now an example. Determine whether the following vector is solenoidal. So this vector is given by V equals to x sine of y, I, plus y sine of x, j, minus z into sine of x plus sine of y, k. So this simply to test whether the divergence is 0. Solution, we check if divergence of V is equals to 0. Now, by definition, divergence of V is given by partial V1 partial X plus partial V2 partial Y plus partial V3 partial Z, where V1 is a component of I, which is X sine of Y, V2 is Y sine of X, and V3 be given by negative Z into sine of X plus sine of Y. Now, this means divergence of V. Now, when you partially differentiate this V1 with respect to X, you get sine of Y, plus when you partially differentiate this with respect to Y, you get sine of x. Differentiating this one partially with respect to z, you get minus sine of x plus sine of y, which is the same thing as sine of y plus sine of x minus sine of x minus sine of y. And once you open the brackets, it should be clear that this sine y and minus sine y cancels out, and also positive sine x and minus sine x cancels out, and this gives 0. So since divergence of V is given by 0, then V is solenoidal. So that is how we work out that given problem. Thank you.